Hello class. So let's continue our lesson, which is still in second order differential equation, but we will be using Laplace transform equation. As you remember, to solve the second order differential equation, there are two methods, which one it should be homogeneous, and the second one it should be non-homogeneous. We already know how to calculate or to find the second order differential equation from homogeneous and also non-homogeneous, but there are several methods for non-homogeneous, which is undetermined coefficient method, variation parameters method, and lastly, the third one, which is Laplace transform. The definition of Laplace transform, it has been introduced by a French mathematician, Pierre Simon de Laplace. It is a neat method, changes the initial value problem to the algebraic problems. The use of Laplace table simplifies the steps of solving and getting the particular solution. We can let ft be defined as a function with 0 to infinity. So we can integrate that function to be e negative st ft with respect to dt. Laplace transform, the symbol of Laplace transform is shown as follows. As you can see here, this is the symbol for Laplace transform with the symbol L translated as the operator. Let's take a look at the example of a Laplace transform. Find the Laplace transform of this function, ft equals to 2. Integrate the function by do the integration of 0 to infinity of e negative st ft dt. As we know ft is equals to 2, we can substitute ft as 2. This will give a result of 2. So integrate the whole function. Let's say we put out the 2 and we integrate est. The integration of e negative st would be e st infinity to 0 over negative s. So solving this integration would be substituting infinity and 0 to t. So substituting infinity to t and also 0 into t. What we get is as infinity divided by something, it will be result to 0. This will result to 1, so it will be 1. So 0 minus 1s will give 1s. So 2 multiplied by 1, we have 2s. The Laplace transform can be converted into a table. As you can see here, this is a table of a Laplace transform depending on certain functions. And here are all the lists of functions that can be used to be converted as a Laplace transform. So let's take a look at these examples. The first function is ft equals to t squared. Second function is ft equals to cosine 4t. This can be calculated using formula or by the table as given before. Here will be the solution for the Laplace transform for ft equals to t squared. As you can see from the table, t squared can be represented by this equation. Laplace transform can be represented by using this equation. Hence, the Laplace equation for t n, which be n here will be equals to 2, will be shown as n divided by Sn plus 1. So n is the factorial of n, s is the complex frequency of the variable. As we know that n is equals to 2, substituting into the formula, we will get a Laplace equation of 2 divided by S2 plus 1. This will give you 2 times 1 S squared plus 1. So the final form will be 2S power of 3. That will be the answer. For the second example, the function is cosine 4t. As we look at the table, it can be represented by this Laplace transform. So we can write this as cosine at equals to s divided by s squared plus a squared. A here is given as 4. Hence, we can substitute a into the formula and we can get this equation. Hence, the final answer will be s divided by s squared plus 16. Now we take a look at Laplace transform in terms of inverse Laplace transform. Laplace transform is written as this. So for inverse Laplace transform, is written as this. L power of -1 is known as the operation of inverse Laplace transform. However, note that L -1 is not equals to 1 over L. Here you can see an example of a Laplace transform. Let's say we have a function of cosine 2t. This will result taking from the table and obtaining the answer will be the Laplace transform of this function will be s divided by s squared plus 4. So the inverse of this Laplace transform would be cosine 2t, which will be go back to the same as the first Laplace transform function. Here we can see a more complex example using the inverse Laplace transform. Given the inverse Laplace transform function to be 3s plus 1 divided by s squared minus s minus 6. We can write this in the form of its partial fraction, where this equation would be converted with the denominator of s plus 2 multiplied with s minus 3. This will give us a separation of a divided by s plus 2 plus b divided by s minus 3. We can multiply this equation with s plus 2 multiplied with s minus 3. Hence, we will get this equation after multiplying it to the equation. Once we get here, we simplify and get this equation where we can solve what is A and what is B. So what we do is we can substitute S equals to negative 2 into the equation, we get if s negative 2, that's 3 multiplied with negative 2 because we are substituting the s with negative 2, and we can get a solution of getting a equals to 1 and b equals to 2. Here we get an inverse Laplace equation after substituting this value of a and b into this equation. Hence, when substituting that into the equation, we will get inverse Laplace of 1 divided with s plus 2 plus 2 divided with s minus 3. As you can see, the inverse of s plus 2, it will be can be referred to as here. So we take a look at this part. This is similar to this one. However, this f Laplace function is in terms of 1 as a minus s minus a, 1 divided by s minus a. What we have is 1 plus s2. So this can be written as 1 plus s negative 2. Hence, this should be equals to, instead of e 2t, it should be e negative 2t. Now we take a look at the second one, which is 2 divided by s minus 3. So this is similar to what we have here, because a will be negative 3. Hence, it will be 2e 3t. So this is correct. So the final answer for this should be equals to e negative, final answer would be e negative 2t plus 2e 3t. There's a slight mistake in this answer. So the final answer would be this one. As you encounter the denominator of the function, we can write if you encounter the denominator of ax plus b, it can be written with a partial fraction of a divided by ax plus b. If you have this, it can be written as this. If you have this, it can be written as this. If you have this, it can be written as this. Now let's find the inverse Laplace transform of this function, which is 8 divided by s power of 3 multiplied with s minus 2 multiplied with s plus 1. Now we can change this function to be as a partial fraction. This will be the partial fraction. All right, so a over s plus b over s squared plus c over s cubed plus d over s minus 2 plus e over s plus 1. So this will be in this partial fraction form. Now we can multiply all of this with s power of 3, s minus 2, s plus 1. This will give a long equation as seen as below. Now substituting the values of, let's say, s equals to 2. If we multiply this value, we will get mostly by cancelling out all the unknowns of A, B, C, and E, leaving us with only D. So D will be taken as D equals to 1 over 3. Now, if you substitute S with -1, we will cancel out all of these unknowns that are 0, and we left out with E. So E will be E equals to 8 over 3. So if we put S equals to 0, we will cancel out all other unknowns, and we're only left with C, which is C equals to -4. If we come to this part, please ignore the underline, or that is the lines on the numbers. So let's substitute S equals to 1. If you substitute S equals to 1, this will be given as equation like this, and as it becomes, if you solve the equation, you will get A plus B equals to 3. So let this be equation 1. Now let's put if S equals to 2. All right. When you substitute the values of S equals to 2 into the equation, you will get -12 equals to 2A minus B. So let this be equation 2. When we simultaneously solve the equation of equation 1 and equation 2, we will encounter A will be -3 and B will be 6. After obtaining all the unknowns for A, B, C, D, and E, substituting into the equation, we get an equation such as this. Hence, by taking each one, we are able to solve the Laplace transform for each of it. Let's take a look at -3s would be similar to this one, hence it should be written as A. A here is 3, should be -3, so it should be written as 3. 6, the second one, which is 6 over s squared, can be taken as this equation. Hence, s squared will be 1. So, yeah. So here, right? N, okay, the n will be 1. So if n will be 1, n will be 1. Okay. So multiply here. All right. So let's take this out. Take this out. So sorry. Let's take a look one by one. Okay. Let's take this out, and s n plus 1. So n here is given as 1 because we have 1 plus 1. Okay, this will be all right. So it will be similar to what is shown here, right? Okay. So here you can see that this will be converted as 6t, and since n equals to 1, it is here shown as 6t, right? Which is 60. All right, let's move on to the other one, which is 4 over s power of 3, which is similar again to this one. Let's take out again n s n plus 1. Since this is s3, s power of 3, which is supposed to be, let's take a look one by one. 2 plus 1 will be given as, which is equals to Okay, so we can write it like this. So this will be f4 t2, right? Yes. Okay, hold on. Let me check. For okay, so a slight mistake here. It should be 8. Okay, 2, 4. All right, should be 8. 4 times 2 should be 8t2 t squared. All right, so this one should be written as 8t squared. Okay, and here let's take a look. This is similar to what we can see here. Okay, so a here would be, okay, let's take a look one by one. So here, so a would be 2. So this can be written as e to t, right? And multiply with 1 over 3, we get 1 over 3 e t2. And finally, s plus 1, which can be also taken with this one. But a here, okay, let's take a look one by one. Okay, so this one would be to take this one, since s minus a should be 1 minus s, sorry, plus 1. This will give us 1 plus s plus 1. So it is similar to this one. So this will be inversely transformed to e, since a equals to 1, negative 1. So e negative t. Okay, e negative t. So this is correct. Multiply with 8 over 3, multiply with e negative t. So the answer will be, there's a slight mistake here. It should be 8t squared. Okay, so thank you very much. This is how you do with the Laplace solution and the inverse Laplace solution.